Your grade M mathematics teacher, Beatrice here. Welcome. Today we are talking about skewness and Kartosis. And we start by saying that frequency distributions differ in three ways. The first way in which frequency distributions differ is average value. The second way in which frequency distributions differ is variability or dispersion. And the third way in which frequency distributions differ is with regard to shape. And this is actually what we are talking about today. So we say with regard to shape, we have two comparable characteristics. Comparable characteristics, and these are namely what we have written up here. So namely skewness and Kartosis. Yes. So we start by talking about skewness. So what is skewness? We say skewness is a measure of symmetry or more precisely the departure from symmetry. Okay, so we continue and say that in terms of skewness, a frequency curve or a frequency distribution may be one, symmetrical. So how does a symmetrical frequency curve look like? A symmetrical frequency curve usually looks like this. It's bell-shaped. So for a symmetrical frequency curve, the mean, the mode, and the median, the three of them are the same value or take the same value. They take the same value. So that is one of the ways in which a frequency curve may be in terms of skewness. Now the second way a frequency curve can be in terms of skewness is that it can be positively skewed. It can be positively skewed. It can be positively skewed. Now, when a frequency curve is positively skewed, it has a long tail to the right. It has a long tail to the right. So let us illustrate that here. It has a long tail to the right. So what happens is that frequency curve will have a peak there, and then to the right we are going to have a long tail, as we have indicated here. So how do the mean, mode, and median relate when a frequency curve is positively skewed? Now, the mode is usually less than the median, which in turn is less than the mean. So in that case, we say that the curve is positively skewed. It has a long tail to the right. Now, the third way a frequency curve can be in terms of skewness is that it can be negatively skewed. Negatively skewed. When a frequency curve is negatively skewed, it has a long tail to the left. It has a long tail to the left, as we are illustrating here. So we'll have a tail there, and the peak will be now to the right. So how do the mean, mode, and median relate in this case? Now we find that the mode is greater, this is where the peak is greater than the median, which is in turn greater than the mean. So suppose students sit for an exam and their marks are put in a frequency table. Would we rather have a positively skewed distribution or a negatively skewed distribution? You see, if we graduate this will be, can assume this is 10 marks, 20, 30, 40, 50, 60. The number of the students, which is the frequency. These are the marks on this side. Here we have, say, 10, 20, 30, 40. So you can find that, you'll see that the peak is at 30 marks. So most students have 30 marks. What alternatively on this side we have the same 10, 20, 30, 40, 50. These are the number of students. These are the marks. This is 10, 20, 30, 40, 50, 60, 70, 80. You can see the peak is at around 70 marks. So if we have marks for students for an examination, we would rather have a negatively skewed distribution rather than a positively skewed distribution. So now let's talk about measures of skewness. Talk about measures of skewness. Now we have what we call Pearson's measure, and we have two of them. The first one is given by mean minus mode over the standard deviation. So that's the first Pearson's measure of skewness. We have a second Pearson's measure. We write it as PS2 is given by 3 times mean minus median over the standard deviation. So that is the second Pearson's measure of skewness. Now we have another measure called the quartile coefficient of skewness. Quartile coefficient of skewness, we denote it as KQ, and it's given by Q3 plus Q1 minus 2Q2, and all this divided by Q3 minus Q1. So that is the quartile coefficient of skewness. We have another one called the percentile. The percentile coefficient of skewness. Percentile coefficient of skewness, we denote it as SKC, is given by 90th percentile plus the 10th percentile minus 2 times the 50th percentile. And all that is divided by the 90th percentile minus the 10th percentile. Now the last one we are going to mention is the moments coefficient of skewness. The moments coefficient of skewness, it is given by the formula A3, which is mu3. That is the third moment about the mean, divided by the square root of the second moment about the mean, and all that cubed. So we are going to talk about moments in another lesson. So those are the measures that we consider for skewness. Now we briefly talk about kurtosis or kartosis of a distribution. Kartosis of a distribution, and we say that kartosis is a measure. It is a measure of whether the frequency distribution is peaked or flat relative to the normal distribution. Relative to the normal distribution. So now we say, so you can see that Kartosis is a measure of peakedness of a distribution relative to the normal distribution. So we say in terms of kurtosis or kartosis, a frequency distribution can be or maybe one very highly picked, picked. So how will it look like? How will a frequency curve look like when a distribution is very highly picked? This is the x-axis, that's the y-axis. So it will look like that. And we say that this very highly picked is seen to be leptocultic or leptocultic. Now the second way a frequency distribution can be in terms of kurtosis or kartosis is that it can be flat picked. It can be flat picked. So I suppose if a frequency distribution is flat picked, it's going to look like that. And it is seen to be platecultic. It is said to be platecultic. Now, the third way, now a frequency distribution can be in terms of Kartosis, is that it can just be normal, not very highly picked and not very flat picked. And we call this the normal way, the normal or mesocultic. So that is the third way in which a frequency distribution can be in terms of kurtosis. Now we conclude by mentioning the measures of kurtosis. Measures of kurtosis. Measures of kurtosis. So we have two of them that we are going to consider. The first one is just given by K, which is a half of Q3 minus Q1, or this divided by P 90th percentile minus the 10th percentile. So that's our first measure of kurtosis. And when we use this measure, we say that for normal or mesocultic distribution, K is 0.263. So now when K is less than 0.263, it will be that way for platecultic, and K will be greater than 0.263 for leptocultic. For very highly picked distribution, K will be greater than that. Now the other measure that we are going to mention is called the moments measure. Moments measure of kurtosis. And it's given by A3, sorry, not A3, but A4, which is mu4 divided by mu2 squared. So this is the fourth moment about the mean divided by the second moment about the mean squared. And we say that for mesocultic, now this A4 is equal to 3. A4 is equal to 3 for the normal. So that we say that kurtosis or Kartosis is sometimes defined by A4 minus 3. And we say that A4 minus 3 is positive for leptocultic, and it is negative for platycultic. And of course, it is 0. It is 0 for normal or mesocultic. So today we have talked about Kurtosis and Kartosis and Skewness. We have seen that Skewness is a measure of departure from symmetry, and Kartosis is about how peaked or not a distribution is. So next time we are going to talk about moments. Thank you.